Hello and welcome to another video. In this video we're going to be working on score after flipping matrix. And in this one you're given a matrix and you can have a move that picks a row and a column and you can flip all the values in that row or column. And then each row is represented as a binary number and the score of the matrix is the sum of the numbers. So you want to turn the highest possible score after making any number of moves. So in this first example, basically you change the row, then the column, then you get these numbers. And so this is 15, this is 9, this is 15. So you get 39. In the second one, you would just change this to a 1, so you'd get 1. So the main thing with problems like this is kind of like playing around with these operations and figuring out like what am I trying to achieve. And the thing you want to recognize here, the first thing you want to recognize is every number counts for more than the whole row after it. So this number counts for more than all of these. This number counts for more than all of these, and so on, right? Because it would be kind of like just having a decimal number. Like imagine if we just have like a number like this, or even a number like this, right? Making this go up one digit is worth more than everything else, because all of these together is less than the digit like after it. So the most significant digit of a number is worth more than the rest of the number combined, right? Because in binary as well, you have like 2 to the, let's say the first digit here is 2 cubed plus 2 squared plus 2 to the 1 plus 2 to the 0. And so 2 cubed is worth more than all of these combined, right? Because 2 cubed is 8 here, and the rest of it is 7. Because by definition, if this bit is on, this bit being on is the same as all of these being on plus 1. So that's the first thing you want to recognize. I want to make my whole, ideally I want to make all of these 1s, and making this a 1 is better than whatever is here. And there's kind of a few ways to turn everything into a 1, and it turns out it doesn't matter which way you pick. So let's make a copy, and let's try 2 different ways. So one way is you just change every row. You do the row operation to make every number that's 0 into a 1, right? So we just say, okay, well, this needs to be a 1, so I'll just flip this row. And then I have my goal. Now that I did that, I can no longer do the row operation, but now I can do column operations. And so column operations, basically, for each column, the number of 1s here, this is just a count. So it doesn't really matter which ones are on. If these 2 are on, or if these 2 are on, it's going to be the same exact thing, because you're doing a sum, right? You're doing, imagine you have a bunch of decimal numbers and you're adding them. So does it matter if I have 1, 2, 3 plus 1, 9, 3, or if I flip these around, or these aren't like this? Does it matter if I have this or I have this? It does not, right? So for multiple numbers, because you're just adding them together, it doesn't matter in what order the column is in at all. It just matters how many do I have for the column. But I can no longer do the row operation. So let me go back here. Okay. So basically now, from here, it doesn't, like I said, it doesn't matter where these 1s are. It all matters is the count. And so once these are 1s, now I'm just gonna do the column operations on all of these, and I'm just gonna try to maximize the number of 1s I have. And so if I do the column operation, I will flip all the 1s to 0s and all the 0s to 1s. And if I do it again, I will revert it. So basically it's a pretty easy strategy. You just count up the number of 1s for each column. And then if the number of 1s is more than half, then you're good. And if the number of 1s is less than half, then you do the flip to get the number of 1s more, right? Because you can either say, let's say you have 3 rows here, you can either say I have my number of 1s that I have originally from doing the count, so let's say count, or you could do the number of rows minus count, right? You can pick one of these, and so if count is less than half, then you're going to want to do this one because this will give you a bigger number. And if count is more than half, you're going to want to do this one. So for this column, we already have 2, so if we flip it, we'll only have 1, so we leave it. For this column, we only have 1, so we'll do a flip. And then for this column, we want to do a flip as well, because then we'd have 3. And so this is our best output. Now notice our strategy here was we said, well, we're going to turn all the rows into ones, and then we're going to do column by column. Now the other strategy is, and you might have thought of this, is you can turn all the rows into zeros instead. And so if you turn all the rows into zeros, let's see what that would look like. So if I turn this row into 0, so I'd flip all these. And then this would be 0, 0, 1, 1, right? And then you can turn them all into zeros, and then you can do the column operation on the first column, and then that would turn it into ones. But it turns out that this is going to give you the exact same result. Because basically, when you turn them into zeros, like if I turn them into zeros, then essentially it's the same thing as turning them into ones and then doing the column operation on every column. So this is going to give you, like if we actually go back to our original thing, so let's actually go back. Okay, I think we're here. So if we turn this into ones, right, this will be like this, 1, 1, 0, 0, I think. And if I do this, turn that into zeros, it would be 0, 1, 0, 1, and then 0, 0, 1, 1. So this is basically the same thing, only everything is just reversed, right? Every 0 is a 1. So what's going to end up happening here is I can take this matrix and transform it into this matrix by just doing the column operation on every column once. So if I do the column here, 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 and here, I'll get this exact same thing. So it doesn't matter what strategy you use, turn the first column into all zeros or all ones, it's going to give you the same exact result. But you just have to pick one. Because then, yeah, at the end here, you will basically then do the column operation here, then you'll do the column operation here, then you don't want to do the column operation here because you already have 2, and then you don't want to do the column operation here. So we get the exact same thing, no matter if I turn everything into zeros or ones. But essentially, that's a strategy, so we can write it down. Let's just say we're going to turn every row into starting with 1, then do the column, or go column by column, and do column operation if number of ones for column is less than half of the total for the column. And then, so the other thing you can do here is basically you can do all of this in place. So you don't actually need to like do these things. I can kind of show you how we do it in place. So let's walk through that. So let's go back to our original example. So let's go back to our 0, 0, 1, 1, and 1, 0, 1, 0, and okay. So this is our original thing. So we're going to say first we're going to turn everything into a 1, but we're not actually going to do this. We're just going to look if we need to do it or not. So for a given row, we can just check, is this value a 0? And if this value is a 0, that means we're going to need to turn it into a 1. That means all of these values are going to be the opposite. So we don't need to actually change them. But when we look at this value, we can say like, okay, let's get this value and let's get the value here. And if the value here is 0, then this value needs to be the opposite. And all we need to do is do a total. And if the value is a 1 here, then this value is correct. So what we can do is we can start off knowing that like, okay, our first column is going to be all 1s at the end because that's just like the best thing to do. So we can start a result and we can just do the total for the column. So we could say result is, so first of all, like what's this 2 value? So this value is, so this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So this is 2 to the 3. Like this bit represents 2 cubed. And all of these are going to be on. So this is just, so far, 2 cubed times how many rows we have. So that's 3. Now we need to check for the next column. Like, what's the total of ones we're going to have? So we're going to check this bit, and we're going to say, okay, this is a 0. But this is a 0 too, which means we're going to actually be flipping this. So this actually is a 1. So we're going to say, okay, that's a 1. Now this is a 0 and this is a 1. So this won't be flipped, so this will stay 0. So we don't need to add anything here. This is a 1 and this is a 1, so this will stay a 1. So our column total for this column is actually 2 because this wouldn't be flipped. And then our column total is 2, and our number of rows is 3. So we can either take 2, or we can take 3 minus 2 if we flip the column. And 2 is better, so we'll take 2. And what value is this? This is 2 squared. So we're going to add another 2 squared times 2. Now we go to the next column, and we check, okay, this is a 1. And this is a 0, so this value is going to be flipped. So this is 0. This is a 1, this is a 1, so that's going to stay 1. This is a 0, this is a 1, so this is going to stay 0. So now our total is either we can take 1, or we can flip, right? Because when we don't show this in the matrix, but really this row ends up being like this because this turns into a 1. So we want to flip here. So if we flip, then what's going to happen here is instead of 1, we'll have 2, right? We'll have, like, this row will look like this, and we're going to flip, so we're going to flip it into these 2. So this will be 2, 2, and we add that as well. So add another, so this is 2 to the 1 times 2. Now for the last column, so this is a 1, but we check, is this row going to be flipped? Yes, it is, because we're turning everything to 1. So that means this is going to be a 0, so we ignore it. This is a 0, this is a 1, so that's not going to be flipped. It's going to stay the same. This is a 0, this is a 1, it's not going to be flipped. It's going to stay the same. So our total is 0, but obviously we're going to want to flip here, right? Because basically we have this. So we're going to want to flip here, so then we can just get 3 minus 0, which is 3. And so for the final thing, we get 3 times 2 to the 0. And if we actually do all these, so this is 8 times 3, which is 24. This is 4 times 2, which is 8. This is 2 times 2, which is 4, and then 3. Right? So we have 32 plus 7, so 39. Hopefully that's correct. Yep. So that's kind of how you do it in place. You're just going to say, I'm going to turn every row into 1, but I don't need to actually turn it. I'll just look at the first value to determine, is my value that I'm looking at the same, or will it be flipped because this is a 0? You do the total for the column, and then you can either pick your current total or the row count minus your current total, whichever one's bigger. Then you just calculate what's that, what power of 2 is that equal to, and then add that to your result, and you just keep going column by column, and then you finally have a total result. So that's what we are going to code. So to start out, we can have a couple things. So we can have rows, we can have columns, and we're going to have a result. So remember our result, we're going to turn the whole first column into 1s. So what's that going to be equal to? So that's going to be equal to, so basically what you're doing here is, this is the same as having a 1 shifted the length of the grid, the number of columns minus 1 times, right? So this is the same as this value here. One of these is the same as this, so this would be equivalent to 8. So this is going to be 1 shifted left. You can like multiply by 2 as well. You can say like 1 times 2 to the, if that makes more sense to you. Shifted left, so this is going to be columns minus 1 times. And that's one of these values, right? Like each one of these ones is an 8. And how many do I have? I have rows of those. So this is going to be times rows. So that's our starting value. Now we are going to loop. We're actually looping column by column, not row by row. But we don't need to loop through column 1. We don't need to loop through this one because we already know this is all 1. So we need to loop through every other one because we're not going to be doing the column operation on the first one because we're turning all of this into 1s already by doing the row operation. So we can say for int call equals, we'll start with column 1, columns less than calls, and then same thing for the row. So we'll start at row 0. So we're just going to get a total here, and we'll initialize it to 0 to start off. So we'll say int call total equals 0. And so here, before getting the value, we're going to check, like, whatever value we're on, what's the value of the first column for that value? And if it's 0, then we need to reverse what we currently have. So we can say call total plus equals. We're going to check. So grid row 0. So if this is a 1, then we're going to leave the value as we have. So this will just be grid row call. And if it's not a 1, if it's a 0, then we'll do the opposite, right? So if it's a 0 and we have a 1, we'll flip it to a 0 and so on. So this will be 1 minus grid row call. Because 1 minus 0 will flip it to a 1, 1 minus 1 will flip it to a 0. So this will basically just flip it. You could do, I guess, like 1 XOR as well, probably, or something like that. Okay. Yeah, so this will basically flip the value if our first value is a 0, or keep it the same if it's a 1. Okay. Now, once we have the total for the column, we're basically going to say we can either keep it the same or we can flip it. And we can take the bigger one out of those. So we can say result plus equals the maximum of call total. Or if we flip it, we're basically going to get the value of rows minus call total. Right? So if there's like 3 rows and we have 1, then we'll flip it, then we'll have 2. If there's like 20 rows and we have 8, then we're going to get 12 and so on. So get the biggest one out of these two. Now, actually, before doing this, we need to, so we're not adding the number of ones here, right? We need to also multiply this number by the 2 value that it represents. So that's going to be kind of like the same thing here. So this will be this part here times, and the number of columns you want to shift it by is actually going to be this. Because when we're on column 1, if you look at this formula here, so this is 1 shifted the column minus 1. So basically this is going to be, actually this is a little wrong. This is, should be this. There we go. So if we're on 1, the number of columns we have here is 3. And we're on column 1, so we'll do 3 minus 1 minus 1. So we would get 1. Oh, is that right? Let's double check actually. Because we should get, oh right, yeah, because there's 4 columns here. Yeah, so this is not, so this is, there's 4 columns here, so this wouldn't be 3, this would be 4. So it would be 4 minus 1 minus 1, we'd get 2. Then when we're on the next column, we'd get 4 minus 2 minus 1, so we'd get 1. Then we're on the last column, we'd get 0, so that's correct. So this is how much you want to shift it by. If this is confusing, like I said, you can just use a power of 2, just figure out like what power of 2 corresponds to your column. That works too. Okay, so we add the total number of ones, like our best result, times the power of 2 that it represents to our result, and finally at the end we just need to return the result. And there we go. So pretty good. So let's go through like the time and space. So we went through our grid, which is obviously n by n. Let's see if we have anything else. So this bit shift is O of 1. Multiply is technically not O of 1, but close enough because the numbers are small. So yeah, so I think this is technically just, I think it's fine saying O of 1. If you did like a bit mask or something where you have to change a bunch of bits, then it would be more, but I think this is fine. So I think this is this, and the space. So this is where we actually managed to be pretty efficient because we just used like integers. We didn't have to actually modify any of this. We just realized like all we have to do is just check the first value to see if we modify. And for a column total, we don't actually have to flip them. All we have to do is just calculate how many there are, and then calculate how many there are if we were to flip them. We don't need to actually like flip any values or anything. So yeah, I think that's going to be it for this one. Hopefully this was a good one. I think this is a pretty good problem to do. Not super hard. And yeah, if you did like the explanation and stuff, and if you have any questions, as always, write in the comments. But yeah, I'll see you in the next one. So thanks for watching.